Okay, so I'm on the virtual enzyme lab, and I'm just narrating over this video because I'm sure some people probably have Apple computers and there's problems using Flash with Apple, and this is a Flash lab. So this is going to serve as, if you can't otherwise access the lab, you can use this. I'm going to just kind of click around and show you different results so that you can be able to do the lab. Okay, so talks about the question you're answering. You can read the purpose and the objectives. It gives you a little background with the procedure. Okay. We're going to click on the TV. It just gives a little background there. And then it says to conduct the experiment, you're going to do these things, which I'm going to do. Okay. You're also going to use the lab printout, the paper. You don't actually print it out. You can, if you want to, you can fill it out on, a Google Doc or on the paper itself and just send it to me. But the lab packet that came with it is where you're going to take data and answer questions. Okay, so it says to do this first.
Enzymes enable molecules called substrates to undergo a chemical change to form new substances called products. Each enzyme acts on a specific molecule or set of molecules called substrates. Each substrate has its own parallel enzyme called the active site. This means that the example components are not the mechanism. However, the enzymes use a circular to form the substrate. And the enzyme is substrate complex. The enzyme acts the substrate or substrates, and this is a common reaction to the current enzyme. After a reaction, the enzyme releases the product and can go on to carry out the same reaction again and again.
Okay, so the analogy I always use in class is a stapler. Let's call a stapler an enzyme called stapler ACE, because ACE as a suffix often describes an enzyme. So it can be used many, many times, but it can only do one job. Okay, the active site is the spot where the actual substrates that the enzyme is going to work on fit in for the job to be done. The substrate would be paper. The job of the enzyme is to it changes shape a little bit when it's working to bond paper together, right? Staple paper together. So the paper would be the substrates, the enzyme would be the stapler, and it works like that again and again. Okay, now notice it says 37 degrees Celsius. This is like body temperature. Okay, so we're looking at the ability of it to function. We're not going to change the temperature, but we're going to change the pH, and we're going to change the amount of substrate that we're adding to whatever enzyme we're looking at. Okay, so first thing I'm going to do is I'm going to make it acidic. Oops. A little less acidic. Not acidic is pH 7. Basic. And very basic, or not very basic, but okay, so I have from the most acidic to the most basic, and I'll start with half a gram. Okay, I'm going to add half a gram to each one of these. Okay, you can only change one variable at a time in an experiment. So since I'm changing for this first little test, since I'm changing the pH, I'm not going to change the amount of substrate. Okay. Let's see where I click here. Oh, okay, here it is. So then I can click on this and get the results. So I've added half a gram of substrate to each enzyme, and I look at the products and this is a measure of if the enzyme did its job. And let's see. This is all the same, but test tube number 3 has the most products. Okay, so pH of 7 produced the most products, less with a little bit acidic and a little bit basic, and the least with more acidic and more basic. Okay, let's reset. What happens if I do the same situation I did, but I add 1 gram? I double the concentration that I added before. Okay, I get the same results, the same trend of results, where I get the most amount of product with pH 7. Okay, the enzyme is working best at pH 7, but I'm actually getting more product than I did when I added half of the substrate. Okay, so when you add more substrate, then I get more product so far. Okay, now let's reset. Let's go down 2. Down 1, up 1, up 2. Let's add 2 grams to each. Wow, look at this, same trend, and even more. So far, the trend has been the highest amount of product at pH 7, a little less as you go down, or much less as you go down the pH scale and up the pH scale. And ask yourself, what is the relationship between the amount of substrate that you're adding and the number of products that you make? All right, so far we've seen a trend. Let's reset. On to 4 grams. We're doubling it again from the previous test. Okay, take a look at the numbers from last time to this time. 96, almost 200, 350, let's say around 200, 100, let's say. Okay, similar trend, but something to note here. I want you to recognize a pattern, a little bit of a pattern, or a little bit of a change from a pattern. Okay, let's try one last time. With 8 grams. Okay, so we're asking the question here, by changing the concentrations like this, is there a limit to how much substrate you can put in to get more product? Let's see. Over 1 minute period of time and letting the reaction occur. All right. How much is formed per minute? Look. How do these numbers compare to the last test I did, and why? Okay, why might we not be changing these numbers per minute of reaction time when you add more? Okay, in other words, when you add more and more and more, how come you can't just get more and more product at a given time? Think about it. Okay, think about like workers on an assembly line. Okay, if their job is to, just say something simple like connect 2 parts together. If you keep giving them parts to connect together, more and more and more and more parts, will they be able to just double and double and double the speed at which they can do it? Think about why or why not that would work. Okay, so the video's at like 9.5 minutes, so I'm going to stop in case there's a 10-minute limit on YouTube. I don't know if that's an old thing that used to be when I used to post videos, but so this is a video you can watch either way, but it's definitely a video you can watch if you can't get the virtual lab to work. Okay.